So today, as we get ready for our quiz, our first one here in our rational expressions with our growth and decay here. Haven't gotten to the logs yet, but we are getting to some of the other parts. We're actually going to start on the other sheet that you got today, because it's just going to give us a little bit of extra practice at seeing how this works. Now, before we even get started, okay, we need to get a little pep talk here at the start. So one of the workshops that I did last week when I had the Institute Day was about grit. Now, this is not what they gave me from that. This is my own thing. But grit basically is, how do you react when things don't go well? And sometimes things don't go well in math. So just a few reminders as we continue to move forward in the semester here. Make sure you're legitimately giving it a go. And when I say no faking, I mean fake is when, hi, I'm going to take a picture of the key, I'm going to copy down all the answers. Woo, I did my homework. No, that's faking. Okay? Actually trying them and looking at the answers then, that would be a legit give it a go. Rebound from flops. I hate using the word failure because it's not failure until you quit trying and time runs out at the end. So if we have some flops, we got to rebound, we got to keep trying, we got to keep pushing. Intentional effort. Okay, push beyond everybody else who's staring at their phones and jamming to music and actually do what you need to do. Okay? Support systems here, you just got to put the effort forth. And then try again. Keep at it, keep at it, keep at it. Because if you do, more times than not, you're going to find at least a level of success that's going to work out well for you in here. So with that in mind, when we look at this first group here on this exponential growth and decay, reminder, okay, which shows growth, which shows decay? I don't need this. I don't need a picture. Because when we're looking for growth and decay, I'm just looking at my b value. Now, a reminder, what's this b value that you are speaking of? Okay, this is what a typical growth and decay function looks like. The only thing that I'm interested in when I'm looking at growth or decay is this part, okay, this b value. Because when I'm looking for growth, my b value is going to be greater than 1. When it's decay, that b value is going to be between 0 and 1. Now that can take on the look of a fraction, it can take on the look of a decimal, but I still have to be careful, which we're about to see as we go through some of these. So, I look at A, and again, the only thing I care about in these, look for whatever has the x exponent. That's what I care about, are those. So when I get to here, I go, okay, that first one, the only value I care about is the 2. So that 2 is going to create for me growth. I don't need to look at the picture. I mean, I could, but I don't need to. 0.5, that's not greater than 1. X value is positive. We'll chat a little bit about that when we hit a little twist here in a little momentarily. 1.3, bigger than 1. You're like, okay, I get what you're saying, dude. It's okay, 0.8, yeah. Okay, so when we see something like that on a quiz or even on a homework assignment, that should go fairly quickly. And I'm not even trying to fool you on E and F. Okay, E and F. The one thing I might say you might want to do on a calculator, possibly, is just kind of look and say, okay, that's the actual value I'm looking at, 1.025. Not much greater than 1, but it's still greater. One minus 0.4, all right? 1 minus 4 is 0.6. 0.6, not greater than 1, between 0 and 1. Decay. Okay, so if we're just looking for growth or decay, stare at that b value. Now the rest of these are going to be applications like we were doing later in the week. Since January 1980, that was a long time ago, the population of the city in Brownville has grown according to the mathematical model, so they did all the growth and decay model for me, where X is the number of years since January 1980. Okay, here's the key. That's my base year. Okay, and we've talked before about what that means. What that means is that's the year where my t value would be, or in this case, I guess we'll call it my x value. Do I want to change that? Yeah. Is 0. So every year after that, we would just add another 1. So if it was like 1981, it'd be 1. If it's 1990, it would be 10. And kind of going that way. So first job, explain what the numbers 720,500 and 1 plus 0.022 represent in the model. Okay? This could be anything. It could be as simple as, my starting value, my starting population. I wouldn't call it principal because it's not money. I mean, I guess you're kind of showing me you understand the concept that way. But that's, the population when I started. Now we're going to bust out a word here that we haven't busted out in a while for the second part. This 1 point plus 0.022 is my growth factor. It's telling me how much the city is growing. Even if I saw something, if this were a quiz question, if I saw the word, hey, this represents the growth that's going on, that's telling me you understand the concept. You understand what's going on. The plus would tell me growth. If it was minus, it would tell me decay. But again, it's those little things that are going to kind of help me when I'm doing the mathematics. What would be the population in 2000 if the growth continues at the same rate? Okay, if my base is 0, and my base is the year 1980, how many years later is 2000? 20. So my x value is going to be 20. So I'm going to take everything else that's already there. Could I plug that into the y equals and scroll down to 20? I sure could. If I don't feel like doing it that way, though, I am A-OK with just typing it into the calculator. And again, since we're talking about people here, now let's think about this. We do not want 3/4 of a person. Okay, that's kind of gross to think about. So round it to the nearest whole person, please. If it's money, okay, cents, that makes more sense. But people, we definitely don't want to do that. And so then it says use the model. That's my model equation to predict when the population of Brownville will first reach 1 million. Okay? This is where I got to go into y equals. So what I'm going to do is I'm going to type this into my y equals. You're like, why is he recopying it? Because what I want you to make note of is what we're going to be looking for is the first time my y value goes over 1 million. So when I plug this into y equals, so a lot of this, it's not that you're having to do a whole lot of math, it's just realizing what's being asked and how do I find it. So I get that typed in, and I pull up my chart, my second graph. Ooh, negatives, that's not helping me very much. So I start looking, and again, I'm looking to see when does that second column, that y column, get to 1 million. We're getting close. Oh, there it is. You're like, wait, that says E. Well, remember, okay, now you're like, wait a minute, you told me before E equals 0. When it's E to a negative, yes. But in this case, maybe it'll help me once I see the E, if I actually put my arrow over there over it, I see this is 1,020,582. Okay, this is my first time it's over 1 million. So somewhere in here, 998,000 to just over 1 million. So it looks like it's going to take 15 or 16 years for that to happen. Okay. So I start to take a peek at some of these, and I'm like, okay, I kind of see where this is starting to go. And again, it's not that we're having to do 1 billion of them. It's just we're going to have to keep practicing a little. We're going to do a couple more on this sheet, and then we're going to jump over to the review. Okay, a population of 800 beetles is growing. Growth plus each month at a rate of 5%. Write an equation that expresses the number of beetles at time x. Okay, now again, when we get to the preview and when we get to the actual quiz, I'll be giving you an idea of what's going on here as far as... Okay, so you'll see something like this when we get to the actual preview, because that's the formula type we're going to be using. So, what do I know? I know my A value. I know how many beetles I'm starting with. I know since it's growing that it's plus. I don't use the plus and minus. It can be either one. Percentages, again, if that's not your strength, knowing that's 0.05, you can always take whatever percentage and divide it by 100 and use that decimal. So that would be my equation. Not solving anything, just making the equation. X is fine, T is fine, whatever you put there. About how many beetles will there be in 8 months? Okay, since my problem is growing by months and not years, I don't have to make any conversions. So I'm just going to plug an 8 in there for my X. And again, you can do that in the y equals and scroll. Or since there's only one value I'm looking for, I can go ahead and just type it into my calculator. Again, these are beetles, so we are not taking partial beetles. Again, kind of a gross concept. So we'll just round to the nearest beetle. But again, it's like anything else. The more practice you get, the more repetition you get, the easier this is going to be. Okay, I got one more I want to play with on the back here. Labels, no. No, I am more interested in the mathematics than I am the other stuff. So if your numbers are good, you'll be in good shape. All right, the last one I want to do is number 6, because we haven't done any money yet. You invest $100,000 in an account with 1.01, I'll get that right yet, interest compounded quarterly. Assume you don't touch the money or add money other than the earned interest. Okay, write an equation that gives you the amount of money in the account after X years. This is the one where we get into this end value thing. And again, this will be right on the preview, right on the quiz. You don't have to memorize it. You just need to know where the numbers go. We'll deal with the final when we get a little closer. More than likely for the final, you'll have like a formula sheet that you'll be able to use. So here, I'm trying to get my y equals. P is my principal. How much did I start with? My rate, again, I can divide that by 100 if I need to in my calculator, but I can't use the 1.01, because if I use that, that'd actually be 101% interest. That'd be awesome. I'd invest my money there. Compounded, there's the magic word, compounded. Whatever word's after it is going to tell me my end value. How many times does quarterly happen in a year? 4. So that's going to be my end. So that goes here. And it also goes up here in the exponent. And I can't flip these around. Bless you. And after X years. So we're going to leave the X, that's going to be my variable. So there's my equation. Okay, there's my model. That's another word that can be used there. So how much money will be in the account after 10 years? How much money will be in the account after 25? Again, I have choices. I could just stick a 10 in, put it in my calculator, enter, stick a 25 in, enter. Or, if you see there's going to be a couple that you're going to have to do, maybe it's worth it to you to put it into the calculator in the y equals. It's kind of a personal preference. But either way, I got to make sure I'm doing a good job of typing things in exactly as I have them written down. Because if I move a decimal point, I change numbers around, I'm not going to get what I'm looking for. Okay, and I don't want to plug in the 10 or the 25 in this part. I want to leave it as x, because then when I go to the chart here in a minute, and I start scrolling down, when I get to the 10, yeah, then you would just do it individually with those. Yep. And it wouldn't be wrong if you put the number in the y equals. It's just all your y's are going to be the exact same value. And I don't want you to think you're doing anything wrong. And then after 25, we're almost there. And I don't care if you use the y value or you're more specific and did $128,682.99. They're both fine. Okay? But that, again, is just to kind of get you a little bit of background as we're going in. It's like an extra note sheet. It's an extra reference to use as you're looking at these. Because if it's been a week since you've looked at this and you weren't doing the homework before, use this stuff to help you do some of it tonight. That way you're going to be ready when it comes time to come in tomorrow. Now, the other part is basically me showing you what the quiz is tomorrow. That would be this. And how you tackle it is going to be up to you. So I look at this first question, and I'm kind of looking through, and I'm like, how many questions are on this? 10. Guess how many questions are on the quiz tomorrow? 10. Okay? So here it is. State whether the function represented is growth or decay. Then give the y-intercept, domain and range, and your end behavior. Okay? Now, I should be able to answer some of this without my calculator. Does that mean I'm going to look and see if you used your calculator and shame you if you did? No. So like here I look and I'm like, okay, b is 5/2. Now be careful. Some of you are going to automatically see fraction and say, ooh, decay. 5 divided by 2 is 2.5. Greater than 1. Growth. Okay? Y-intercept. There are no shifts here. No shifts means my y-intercept basically is my a value. But again, be cautious. Your y-intercept is not y equals 3. It's not just 3. It's a coordinate. You're like, well, what if I don't know that? Okay, we're not sure. Like I said, there is no shame, especially on a 10-question quiz. You got time to plug it into my calculator. Again, x is an exponent. Take a look at the picture. Oops. Oh, window range. Hey, that's good that we kind of got that to play with. Oh, look at this crazy person. Okay. Our mins are -10. Our maxes are 10. If sometimes it's cray-cray, fix it on your own. You can bring it to me. I'll help out too. All right, now let's look at the graph. Now it's a little more normal. Up to the right. I'm good on my growth. Looks like it's going through at about 3. Let's double check. Get back to normalcy here. Okay, I notice, remember, with my y-intercept, that occurs when x is 0. So even if I didn't know this before, I go to where x is 0. Oh, it's 3. Okay, so that's another way I can do it. But now, my domain and my range. Again, if I have the picture, it might make it easier. But some of this we've discussed a whole lot before. Domain is the no-brainer question. It's -infinity to infinity, period. Shift, doesn't matter. No shift, doesn't matter. It's still going to be that value because it goes forever to the left and stretches out and keeps going forever to the right. Range, a little different. It goes up forever because remember, range is my y values bottom to top. But it doesn't go down forever. What value am I getting close to but not crossing? 0. And I'd see that even if I started to look at my chart, I start looking towards the left and oh, there's that e to the negative. But I'm getting really, really close to 0. And this is going to be true unless, okay, range. It's going to be this unless there is an up or down shift. Now again, if I forget that is all lost, no, I still got the picture to look at. But that's something for me to keep in mind. I always like to try and help things stay simple if I can. So the last thing is going to be my end behavior. And there's even a connection with this that we have. And here's the connection. When I'm doing end behavior, okay, domain, as we knew before, is our x values. So whatever my domain is, those are the values that are going in down here. So those will always be negative infinity and positive infinity. Okay, that's nice. My range values are my y values. We've always said f of x is a fancy way of saying y equals. So these guys are going to go into these slots. Now here I got to think a little bit. So maybe I want to get my picture back so I can get a little help with this. So as x goes to negative infinity, as x goes to the left, so we're going to the left here, is my y value getting closer to 0 or up forever to infinity? It looks like it's kind of leveling out here by 0. And as x goes to positive infinity, as x goes to the right, what's happening to y? It's going up, 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 up to positive infinity. That's how all this stuff connects together. Domain and these x's together. F of x or y in my range, they go together, and that's going to be true on all of these. And so as I look at number 2, this is where I'm going to have to be a little careful, because I'm going to look at this at first, and if I go the Harty plan, the Harty plan usually is, I'm just going to look at it. Look, my b value is a half. I'm going to mark this as decay, because it's between 0 and 1, and my y-intercept, it's just going to be this value. It's 0, 4. So I'm feeling pretty good about myself, giving myself a pat on the back, and I'm like, yeah, I got this. I'm going to rock this quiz out, and I'm typing everything. Make sure you take everything, including the negative on your x with your exponent. And I'm stressing that here for a good reason. When I look at the graph, I kind of sit here for a minute and go, uh-oh, maybe I don't get something. This is supposed to be decay, but it looks like growth. What's the deal? The deal is right here. That negative exponent, that negative x, makes my 1/2 to the negative x act like it's reciprocal. So if instead of seeing 1/2 to the negative x, I saw this, I saw 2 to the x, ooh, 2 isn't decay. No, 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 no. It's growth. Okay, so that negative exponent will make this the opposite, the flip of whatever's inside. So I got to be careful, but I'm going to see the picture anyway, so it'd be all right. Well, with that in mind, that's going to make the rest of my life easier. Domain's going to be the same. Did I have any up or down shifting? Nope. Range is going to be the same. Flash. And since my picture is very similar now to my last one, my end behavior is going to be very similar to my last one. Because just like before, my domain values go with my x's, so that's kind of a no-brainer. And just like before, as I'm heading to the left, I'm getting closer and closer to 0. And as I head to the right, I'm getting closer and closer to positive infinity. Even if I wasn't sure for some reason, I got a 50-50 shot as long as I can keep together. Domain goes with x, range goes with f of x. Okay. But the calculator can give me a lot of help if I need it. So then we get to the graphing. Now again, I'm going to have some general ideas of what's going on, but I'm not expecting you to know all this off the top of your head. Just make sure when you're typing this in, this -2 is not in the exponent. See, if I just keep typing, oh, -2, that's not good. We don't want that. We want to hit the right arrow. Move that up a little. The right arrow. So the -2 is not up there. So I'm going to pull my chart, and then we're going to chat about some stuff. So the first thing I kind of think in my head is, okay, my B value is 2/3. This is going to be decay. So when I go to graph it, it's probably going to go down to the right. The other thing I notice as I start to graph this is that I have a shift this time. When it's up in the exponent, it's left or right. When it's here, it's going to be up or down. So my shift is going to be down 2. Now that's going to come into play here. So I start plotting some of my points here. Let's see what I can come up with. And I'm not going to get whole numbers everywhere. That's going to happen too sometimes. Whoops, that's down here. Let's look at the picture as we're doing this so we can see what's going on. Now that looks kind of interesting, but we'll graph it first. And again, you don't have to make every single point on here as you're doing this. That's not a complete necessity. But what you're going to want to pay attention to is as you start plotting points, you're like, hey, what number am I starting to get close to? And it looks like I'm starting to get eerily close to -2. Now, do I have to draw this little dotted line in? No. But here's why I would think about it. As I draw my graph, I don't want to go below that value. If it's getting close to -2, I don't want to go below -2. Because otherwise my graph's not going to be accurate. But here's where that really is going to come into play. So pull this up a little bit. Okay, my domain, I've said it before, I'll say it again, it ain't changing. That should be the easiest answer in every single question where it's asked for. The range, though, it still is going up forever. Okay, that's still going to go on the right. That doesn't go on the left just because it's decay. But my range is moved. Because up above we said unless there's an up or a downshift. Well, there's a downshift. So that downshift is going to move my range. The picture tells me that, the chart tells me that, and me knowing that a downshift changes that, And I can kind of play with it. And that's going to be true as we do all of these. Okay, there are tons of hints in here to help you get to a place that you want to be. Okay, x minus 4, everything's up in the exponent this time. Now, that minus 4 is not like making it negative. When I graph it, it looks like it should be growth. And there it goes. My shift this time, being up in the exponent, is right 4. Now we'll see if that makes a difference here in a minute. So I start looking at some of my points because I need to graph this sucker. And I start to look at my points as I'm going along here. And I start to notice, oh, there's the e's. I'm getting really close back to 0 again. You're like, but wait a minute. Why am I getting close to 0? I had a shift of 4. But what direction is the shift? right. Is it up or down? No. So that's going to have no impact on my range. My domain still is not changing. My range, we said, let me pull that back into play, is always going to be 0 to infinity unless there's an up or a down shift. Well, there's no up or down shift. So my range isn't changing. And that's what we're trying to play with here. So when we're doing these, now we're going to go back into kind of some application type. If f of x is 7 to the x, and g of x is 7 to the x minus 3 plus 2, explain how to obtain g of x from f of x. What's the transformation? What are the shifts? It'll always be the second one you're looking at. The first one won't have any. But my job is going to be to figure out, what does this negative 3 and what does this 2 mean? So I've got to remember, what do they mean? Well, up here in the exponent is my left or my right shift. And it's the opposite, because it's x opposite of h. So left is going to be plus, right's going to be minus. So I see minus, right 3. Values on the end are my up, down. Up is going to be plus, down is going to be minus. That you do have to know. And we're going to up 2. And that's all I'm looking for. Okay, we're not looking for anything fancy. I'm just going to get that plugged in there and figure out now what my shifts are. And to be honest, you might even be able to punch that in on your calculator if you forgot and get a little help there. So, here I can actually refer to this now. The amount of radioactive isotope decreases, in bold for a reason, 4.5% per year. If a sample originated with 245 grams, determine the number of isotope remaining after 15 years. Formula's there. I got to figure out the plus minus, which shouldn't be too hard. 245 is what I started with. 1 minus, remember, 4.5%, get it into its decimal form. Whether it's using your brain, left 2 places, or the calculator, and it said 15 years, so that's going to be my time. I can do this in y equals, I can do this just on it, no, it doesn't matter. And again, if you put 122.8, if you put 123 and go to the nearest, they're both telling me you know what you're doing. And that's all we're looking for. I probably could have put it in the blank, but hey, the calculator was covering it up. But again, you practice, that becomes really easy. All right, a city's get it in there. A city's population is currently 45,600 people. But it grows. It gets bigger at 2.3% each year. Write an equation to represent the city's population. Okay, we'll stop there. Again, the equation's here. I'm starting with 45,600. It's growing, so that's plus. Got to get this into my decimal form again. All I was asked for is the equation for the first part. And I can use t, I can use x, doesn't matter there. But then it continues. Then, calculate how many years it will pass before the population reaches 60,000. So when is y going to be greater than 60,000? Well, we know we got to go this route to figure that out, at least in an easy way. So I get that in there. I look at my chart, and I just start scrolling until I see the magic number, a number larger than the magic number show up. Oh, there. Bigger than 60,000, less than 60,000, somewhere in here. 12 to 13 years. You're like, okay. You invest part of your summer income in an account that collects 4% interest continuously. How long will it take for the balance to triple? Okay, lots of things going on here. Here is the equation. Use that one. So, how much did I start with? Oh, didn't tell me. Make one up. So, we're going to make, because I'm boring and I do the same thing every time, I'm going to make it 1,000. So, I guess I could put that here. 1,000. E is a value. We'll chat about that again here in a second. My rate is 4%. I don't know the time. But here's the one part of the equation I do have to work with. How long will it take for it to triple? Whatever 3 times my principal is goes here, and now the contest becomes get my equation part, and again, to get E is second, and ln, it's right next to the 4 button down there. It'll automatically turn that E into an exponent part for you, which is nice. I don't have to think about that. And yes, I will have the second ln is E up somewhere tomorrow. And so I'm looking until I get to 3,000. There we go. Ooh, that's a long time. I need to find an interest rate that's better. 27 to 28 years. And we're set. So again, make sure you use the formula that's there. Do not get creative. Suppose you invest $1,200 in an account paying 5% interest compounded monthly. Find the account balance after 9 years. Everything's there. Got to make sure my interest rate is a decimal. Monthly. How often does the event occur in 1 year? Absolutely. And all the numbers are there for me this time. I'm not looking around for something cute or fancy. So I literally am just going to type the equation I just produced. Into my calculator. Hit enter. And move this around a minute. And again, this is not going to be one of those if you write 1880, if you write 1881, or if you write it with cents. I'm taking them all. Because again, you're showing me you've got the idea. Last one. You are trying to decide which apartment to rent. Choice A's contract charges $300 a month, but the cost will increase $20 per month. Choice B's contract charges $200 per month. It will increase 4% each month. Which apartment is more economical? Justify your answer and be sure to explain the time of the contract. Okay. A, B. Okay. Choice A charges $300 per month, but the cost will increase $20 per month. That's where my X has to be. So if I'm there for 4 months, that's what my value would be. If I'm there for 24 months, that's where my X is going to be. Choice B's contract only charges $200 per month, but increases by 4%. Got to go to the decimal form. Can't use 4x. That'd be 400%. Holy cow. Which apartment is more economical? Okay. You're like, well, how do I tell? Here's what I would do. I would take my calculator and I'd go to y equals. I'd type in my first equation. Once I get that typed in, I would hit the down arrow and I would type my other one in. Because this is going to let me do a side-by-side comparison. I'm going to pull up my chart. Okay, let me get back up here. Okay, so here's my first month. Choice A is 300. Choice B is 200. And I start to look. And I notice I just did something wrong. This is not supposed to happen when I'm doing videos. Ever. I'm like, why isn't that not increasing enough? Because I didn't use the right formula. Shame on the math teacher. I guess it goes to show that I need to have a little grit here too and keep trying even though I messed that up. All right, let me get this right now. Okay. That's what I'm looking for. Now let's see if this gets a little more, this is going to get a little more interesting now. Okay. So you start to look and you're like, well, I'm scrolling down and I'm like, first column's still bigger. And it's still bigger. Harty. Dude. Like, I'm definitely going to do this one. And what you're going to find out, it would take a really long time. I mean really long time. You're still scrolling. You're like, dude, do I really need to keep scrolling? I'm doing this just to prove a point now. Okay, here we go. It took, okay. I would choose, no I wouldn't. My gosh. I would choose B. You're like, why would I choose B? Because it takes 47 months for B to cost more. I mean, even if you looked at one of these and didn't go that far, you're like, I'm going to stay there for a year. And then you look to 12 and you're like, for the first 12 months, you know, B's cheaper. Okay, but you've got to have some logic in here. It can't just be, I'll do B. Okay, why? Oh no. You know, look for something like, when's it going to, you know, cost more? Or I'm only going to stay there a year, so I'm going to look at this, something like that. So I'm going to make you use a little bit of application here. But again, the quiz itself looks a lot like this. If you need another copy of this to take with, I still have extras up front. Okay? But do some time on your own with this, even though this is easy and pretty much kind of guiding you along. If you're not careful, it still could be tough.